Hi, in our past few videos, we have looked at simple examples of how to go about finding unknown angles and unknown sides in one triangle. But in this course, you will need to find unknown sides and unknown angles in more than one triangle at a time. So let's look at some examples. Find the value of x and y correct to two decimal places. Now, in this triangle, we have an angle A of 31 degrees, AD is 14 units long, and DC is 22 units long. BD takes on the value of x, and side BC takes on the value of y. These are the two sides we need to find. We are also shown that angle BDC is a 90-degree angle. In geometry, we learned that a straight line always has an angle of 180 degrees. And line ADC is a straight line. So if angle BDC is 90 degrees, then angle ADB must be 90 degrees as well. And I'm going to mark this on our diagram in green. Now we have a right angle triangle BAD. So let's mark this triangle in red. Let's find the hypotenuse by drawing a line from the 90-degree angle to the opposite side. We have not been given a value for the hypotenuse, so we cannot use it to solve for x. But let's mark it as h. This triangle also has a 31-degree angle, so let's use this to find the other two sides. Let's draw a line from our angle to the opposite side of the red triangle. This is our opposite side. It is the side we have to solve for. So let's make a note and we can say the opposite side O is equal to x. Now let's find our adjacent side. This lies next to our angle. We have just found that our hypotenuse is up here, which means that this is our adjacent side. It has a length of 14 units. So we can make a note and we can say the adjacent A is equal to 14. Now we need our trigonometric ratios. So let's write them at the top of the page. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to the adjacent over the hypotenuse. And tan theta is equal to the opposite over adjacent side. Now we have an angle of 31 degrees, our adjacent side, and we need to solve for x, which is our opposite side. So we need a ratio that includes the opposite and the adjacent, and tan uses both of these. So now we can say tan, instead of theta, let's use our angle of 31 degrees, is equal to the opposite side O, which is x, over the adjacent side, which is 14. Now, to get x by itself, we have to multiply both sides by 14. And we get 14 multiplied by tan 31 degrees is equal to x. And now we can take our calculator and we say 14 multiplied by tan 31 degrees, close the bracket, is equal to 8,412. Let's round off to two decimal places. And we see that x is equal to 8,41. Let's put this in our diagram as well. And now we can make some space and move on to finding y. Let's make our whole triangle blue again. Now, y is the side of the right angle triangle BDC. So let's make this triangle red. In this triangle, we only have a 90-degree angle. So without another angle to work with, we cannot use trigonometry. But because we've now solved for x, we have two known sides of this triangle. And now we can use Pythagoras. The way we write down the theorem for Pythagoras will depend on whether or not we are looking for the hypotenuse. So let's find the hypotenuse in our triangle. Let's draw a line from the 90-degree angle to the opposite side. And we see that the unknown side is our hypotenuse. This is the side we need to find. So we can write down our theorem as the hypotenuse is equal to a squared plus c squared all under square root. In this case, our hypotenuse is y. So we can say y is equal to one known side, let's say 8,41 squared, plus the other known side, 22 squared, all under a square root. Now we can take our calculator and we can say 8,41 squared plus 22 squared is equal to 554. Let's square root. So we say square root answer is equal to 23,552. Let's round off to 2 decimal places. And we see that y is equal to 23,55 units. Let's look at another example. Here we have two smaller triangles inside a larger one. And again, we have to solve for x and for y. Now, x lies in triangle ACD, but we don't have the length of any sides, so we can't solve for x just yet. If we look at y, it lies on triangle ABC, but without a 90-degree angle, we cannot use trigonometry or Pythagoras to solve for y. So where do we start? If we look at angle D, this 90-degree angle, we can see it lies on triangle ACD, but it also lies on the larger triangle ABD. So let's make this triangle red. Let's draw a line from our 90-degree angle to the opposite side, and we can find our hypotenuse. AB has a length of 11 units. So we can make a note and we can say the hypotenuse H is equal to 11 units. Next, let's look at our 50-degree angle and we draw a line to the opposite side. In this case, we don't have a value for the opposite side, so we cannot use this to solve. Now we need to find our adjacent side. We have just found that this is our hypotenuse, which means that this must be the adjacent side because it lies next to our angle. This side, BD, is equal to our unknown side x and our unknown side y. So let's make a note of this and we can say BD is equal to x plus y. This is our adjacent side, so we can say the adjacent A is equal to BD. Now, we may not be able to solve for x or y just yet, but we now have enough information to solve for BD, which is the sum of x and y. Now we have the value of an angle, the length of the hypotenuse, and we need to find the length of the adjacent side. So we need a ratio that uses the hypotenuse and the adjacent sides, and cos uses both of these. So now we can say cos, our angle, 50 degrees, is equal to the adjacent side, BD, over the hypotenuse, which is 11. Now we need to get BD by itself, so we have to multiply both sides by 11, and we get 11 multiplied by cos 50 degrees is equal to BD. And now we can use our calculator. So we say 11 cos 50 degrees, close the bracket, is equal to 7,0706 and so on. But this is not our final answer. So to be safe, let's round off to 4 decimal places and we can write our answer as 7,0707. Now we can make a note of the length on our triangle over here. We also know that BD is equal to the sum of x plus y. So let's make a note of this as well. Earlier in this question, we said that we couldn't solve for x because in our triangle ACD, we didn't have the length of any sides. But AD, this side over here, is also part of the larger triangle ABD. And now we have 2 known sides, which means we can use Pythagoras to find the length of AD. We already know the hypotenuse is 11 units long. So now we can write down the theorem for Pythagoras for the unknown side is equal to the length of the hypotenuse squared minus the length of our known side squared, all under a square root. Our unknown side is AD, so we can say AD is equal to the length of the hypotenuse, 11, squared, minus the length of our known side, 7,0707 squared, all under a square root. Now we can take our calculator and we say 11 squared minus 7,0707 squared is equal to 71,005, but we still need a square root. So we can say square root, answer, is equal to 8,4264 and so on. Let's round off to 3 decimal places. And this is our length for AD. Now we have a length for side AD, so let's put this into our triangle as well. Let's make some space and make our whole triangle blue again. Now in triangle ACD, we have a 90-degree angle, another angle of 65 degrees, and we know the length of AD. So now we can use trigonometry to find x. Let's start with a 90-degree angle and we draw a line to the opposite side. This is our hypotenuse. But we don't have a value for the hypotenuse in this triangle. So let's mark it as h. And now let's look at our angle of 65 degrees. Let's draw a line to the opposite side of the triangle. And we see that AD is the opposite side. It has a length of 8,426 units. So let's make a note up here, and we can say the opposite side O is equal to 8,426. Now we can find our adjacent side. The adjacent side lies next to the angle, but it is not the hypotenuse. We can see where our hypotenuse lies, which means that this must be our adjacent side. This is the side we need to find. So up here, we can say the adjacent side A is equal to x. Now we have an angle, the length of the opposite side, and we need to find the adjacent side. So we need to use a ratio that includes opposite and adjacent. Our tan ratio uses both. So now we can say tan, instead of theta, let's use our angle of 65 degrees, is equal to the length of the opposite side, 8,426, over the adjacent side, which right now is simply x. Now to get x by itself, we need to move it out of the denominator of the fraction. So we need to multiply both sides by x, and we get x multiplied by tan 65 degrees is equal to 8,426. Finally, let's divide both sides by our tan ratio, and we get x is equal to 8,426 divided by tan 65 degrees. And now we can take our calculator and we can say 8,426 divided by tan 65 degrees, close the bracket, is equal to 3,929. Let's round off to 2 decimal places. And we see that x is equal to 3,93. Now we have a value for x. We can find our value for y. We know that x plus y is equal to 7,0707. So if x is 3,93, to find y, we can say y is equal to 7,0707 minus 3,93. Let's take our calculator, clear it up. We say 7,0707 minus 3,93 is equal to 3,1407. Let's round off to 2 decimal places, and we see that y is equal to 3,14. Let's do one last example. In triangle PQR, PR is equal to 20 centimeters, QR is equal to 22 centimeters, and the angle PRQ is equal to 30 degrees. The perpendicular line from P to QR intersects QR at X. Calculate A, the length of XR, B, the length of PX, and C, the angle QPX. Now, in this case, we have not been given a triangle, so we need to draw our own. Let's make some space. When drawing your own triangle, it does not need to be to scale. Also, we have not been given enough information to determine if this is an isosceles or scalene triangle. So when drawing a diagram, it can be a simple triangle like this. Now we can name it P, Q, and R. Before we start answering the questions, it is always a good idea to put your given information into your diagram. The question tells us that side PR is 20 centimeters long, so we can put this in over here, and that QR is 22 centimeters long, so we can put this down here. PRQ is an angle of 30 degrees, so let's draw in an angle and fill in 30 degrees. The perpendicular line from P to QR intersects at X. So let's draw a line from P to QR. The point of intersection is X, so we can name it on the diagram. The question tells us that this line is perpendicular to QR. When lines are perpendicular, they are at a 90-degree angle to each other. So let's draw a 90-degree angle over here. Now we can start with part A. Calculate the length of XR. XR is part of the line QR. The question tells us that PX is perpendicular to the line QR, which means that the angle PXR is also 90 degrees, and we can mark this in green. XR is now one side of a right angled triangle PXR. So let's make these sides red. Now in this triangle, we have a 90-degree angle, a 30-degree angle, and a known side. So we can use trigonometry to find the length of XR. Before we can decide which ratio to use, we need to determine where the hypotenuse lies. So let's draw a line from our 90-degree angle, and we see that this is our hypotenuse. It has a length of 20 centimeters. So we can make a note up here, and we say H is equal to 20. Now we need to determine the other sides of the triangle in relation to the angle. Let's draw a line from our 30-degree angle to the opposite side. The opposite side of the triangle at the moment has no value, so we cannot use it to solve, which means we now need to find our adjacent side. The adjacent side is next to the angle. We know that this is our hypotenuse, which means that XR is our adjacent side. And we can make a note as well, and we say the adjacent side is equal to XR. Now we can find the best ratios to use. So let's write down the ratios for sine, cos, and tan. Now we have an angle and the length of the hypotenuse. We need to find the length of the adjacent side. We need a ratio that includes both of these. And cosine uses both the adjacent and the hypotenuse. So now we can say cos, instead of theta, let's use our angle of 30 degrees, is equal to the adjacent side, XR, over the hypotenuse, which is 20. Now we need to get XR by itself. So let's multiply both sides by 20. And we get 20 cos 30 degrees is equal to XR. Now we can take our calculator and we say 20 multiplied by cos 30, close the bracket, is equal to 17,3205, round off to 2 decimal places, and we see that XR is equal to 17,32, and we can write it on our diagram over here. Let's tidy this up, and now we can move on to part B. Calculate the length of PX. Now in our triangle PXR, If we draw a line from the 30-degree angle, we can see that PX is our opposite side. So let's make a note of this over here. And we say O is equal to PX. Now we have an angle and another two known sides. So we can use trigonometry to find the length of PX. Now we can use the adjacent side, XR, which is 17,32 centimeters, or we can use the hypotenuse PR, which is 20 centimeters. You can use either, but it is easier to use a simpler number. So we are going to use the hypotenuse, which is 20 centimeters, and we can make a note of this over here. Now we have an angle, the length of the hypotenuse, and we need to find the length of the opposite side. So we need a ratio that uses both of these, and sine theta uses the opposite side and the hypotenuse. So now we can say sine, our angle, 30 degrees, is equal to the opposite side, px, over the hypotenuse, 20. Now to get px by itself, let's multiply both sides by 20. And we get 20 multiplied by sine 30 degrees is equal to px. Now we take our calculator and we say 20 multiplied by sine 30, close the bracket, is equal to 10. So we can see that px is equal to 10. Let's write 10 on our triangle as well. Now we can clear this up and finally move on to part C. Calculate the angle QPX. Let's make our whole triangle blue again. QPX is the angle up here. It lies in triangle PQX. So let's make this triangle red. Now in this triangle, we have a 90-degree angle and we know that PX is 10, but we don't have enough information to find the unknown angle. Earlier in this question, we said it is very important to write down all of the given information on your diagram, and this is a perfect example as to why. When we drew our triangle, the question told us that line QR is 22 centimeters long, and in part A, we found the length of XR to be 17,32 centimeters long. Now, QX lies on the larger line QR. So to find its length, all we have to do is take the length of QR and subtract XR. So now we can say QX is equal to the length of QR, 22 centimeters, minus the length of XR, 17,32, and we get an answer of 4,68 centimeters. And we can make a note of it on the triangle over here. Now we have the value of two sides and we can find our unknown angle. Let's draw a line from the 90-degree angle to the opposite side, which we know is the hypotenuse. We don't have a value for this side, so let's mark it as H. Now let's look at our unknown angle and draw a line to the opposite side. QX is the opposite side and has a length of 4,68 centimeters. So let's make a note of this over here. We say O is equal to 4,68. Finally, we can find our adjacent side. We know that this is our hypotenuse, which means that this must be our adjacent side. PX is 10 units long, so we can make a note of this, and we say the adjacent side, A, is equal to 10. Now we have the opposite side and the adjacent side, and we need to find an unknown angle. We can use a trigonometric ratio that considers the opposite and the adjacent, and tan considers both of these. So now we can say tan, let's say angle QPX is equal to the value of the opposite side, 4,68, over the value of the adjacent side, which is 10. Now we need to get the angle itself on one side of the equal sign, which means we move tan to the other side. So now we have angle QPX is equal to, we're moving tan, so this becomes tan to the power of -1. Let's open our bracket and fill it with the fraction 4,68 over 10. And now we can close our bracket. Let's get our calculator. We've got tan to the -1. We're going to say shift tan. In our bracket, we now say 4,68 divided by 10. Close our bracket is equal to 25,079. Let's round off to 2 decimal places, and we see that our angle is 25,08 degrees. And we have now completed this question.